So, what's happening this week? A Utah national park scans for safety and serenity. The Paris Air Show made France a simulation nation. The world's largest 3D-printed building, smack dab in a Middle Eastern desert. A Hawaiian research initiative leverages photogrammetry and 3D scanning for an engrossing study on extinction and invasive species. And an AEC Error of the Week, also in Hawaii, that had problems the world's thickest hula skirt couldn't cover. Honor Teddy Roosevelt and splurge for that National Park Lifetime Pass. Recappers, we are road tripping to one today for a lead story on LiDAR for smarts, safety, and upkept serenity. Rock is the core of it, just like it was in the formative National Park LiDAR operation 16 years ago. Folks, that's when the world met Walter White. So, story goes, in the arid heart of central New Mexico, where the ruins of ancient pueblos and 17th century Spanish missions rise from the earth, a quiet technological revolution of 3D scans and GIS unfolded at Salinas Pueblo Mission's National Monument. Tasked with safeguarding the fragile remnants of the Abo Mission Complex and the enigmatic Abo painted rocks, the National Park Service turned to an innovative solution, something called terrestrial LiDAR scanning. The most concerning obstacle at the onset was documenting the painted rocks and mission ruins in a way that avoided any disturbance to the fragile structures and rock art, a challenge that LiDAR proved uniquely suited to overcome due to its non-contact nature. HDR and E2M, entrusted with this mission, brought state-of-the-art gear to capture every nuance of the weathered stone and intricate petroglyphs. The process was both scrupulous and awe-inspiring. Using a Konica Minolta high-speed terrestrial scanner for the painted rocks area, the team collected millions of georeference data points with astonishing precision. Each scan recorded the contours of walls and carvings, but also the subtle interplay of light and color, producing ultra-high-density point clouds imbued with both intensity and RGB values. High-def photographs were also taken to enhance the visualization of the rock surfaces. The data, processed through Applied Imagery's Quick Terrain Modeler, revealed a digital landscape as vivid as the physical one, a perfect echo of history, preserved in 3 dimensions. And considering how formidable of an opponent data interoperability was, the relief was surely sweet. For the first time, conservators and archaeologists could study the missions and rock art in unprecedented detail, monitor their slow transformation under the relentless New Mexican sun, and plan restoration efforts with scientific accuracy. The LiDAR scanning at Salinas was part of a broader, multi-year effort to document the pictographs, paintings, and cultural significance at the Abo Painted Rocks site, spanning from 2008 to 2010. But beyond preservation, the data produced contributed to regional education and interpretive efforts, strengthening cultural connections with surrounding Hispanic and Pueblo communities whose ancestry is tied to the monument. And it's still all going. Just 2 months ago, a closure occurred so staff could capture the church, convento, and sections of the interpretive trail to ensure structurally vulnerable areas will remain tip-top. And, unsurprisingly, photogrammetry has joined the 2025 party. What a wonder. The project's meticulous and non-invasive digital documentation set a new standard for heritage management and preservation within the NPS. LiDAR scans and 3D GIS demonstrated how pioneering tech could serve stewardship, capturing the spirit and substance of irreplaceable sites for generations to come. In doing so, it inspired a wave of digital preservation efforts across America's national parks and monuments, forever changing how we protect our collective past. And as we'll get to shortly, even protect our roads and the drivers on them. So good job, New Mexico. Breaking bad and scanning well in the same year? Hey, can we make meth out of bear spray? Can we get a PA or intern on that? Okay. Hit those show notes for some quick caps on July's prominent contact releases. 57K scanning tech is paying off for Baltimore crime investigations. The Wire lists, anyone? New drone release is a new standard for surveying. What a trio AI Splats and Revit just became. BIM-driven construction cost model for water conservancy engineering. And Apple eyes Vision Pro upgrades. And we're eyeing recap number 1. Bryce Canyon National Park had the Splendor. Now it's got the render. Danger Falling Rocks has never looked so beautiful. Because one of the best parts of Utah's Bryce Canyon National Park is, well, entering it. The signature Red Canyon arches were crowned a century ago as the welcome to, then, Utah National Park, and they've since become iconic. But for stone, with a century's tenure often comes erosion. That means the occasional rock succumbing to gravity and leaving its mark on either your ride or Utah State Route 12. But now, thanks to some nifty Utah Department of Transportation LiDAR, the arches will remain much more intact, and so will your windshield. Now in Phase 2 of a 6-year maintenance project, newly secured funding means newly added drones, sensors, and terrestrial scanners. They'll be collecting more data on the arches than the park has all-time selfies for erosion monitoring and, in turn, a more rapid response by UDOT. Quote, "We believe good roads cost less," explained James Corney, UDOT Structures Project Engineer, to the American Association of State Highway and Transportation Officials. Quote, "That's why we're prioritizing extra monitoring of these arches, because preserving and maintaining our roads instead of responding reactively to larger problems costs the taxpayer less in the long run." Engineers will combine the data to monitor deformations, rockfall, displacement, and anything else that could yield danger, and a less intact beacon of American beauty. Just not the Kevin Spacey kind. It seems he's a bit unorthodox. Recap number 2. Simulation innovation was to the Paris Air Show what butter is to the croissant. C'est la vie translates to that's life, a reluctant acceptance of an unideal fate, in a sense, complacency. And the 2025 Paris Air Show could not have been more antithetical to the notion of complacency as it pertains to tech above us, yet for us. Simulation software, AI, mesh generation, and LiDAR surveys took center stage, as exhaustively detailed in a post-game analysis by Digital Engineering 24/7. Among several behemoths highlighting accoutrements were Airbus with a #humble brag of securing $21 billion in orders and highlighting its use of AI to augment engineering and simulation. Catherine Jeston, Airbus's Executive Vice President for Digital, emphasized that AI is becoming imperative in aerospace engineering, stating that familiarity with AI tools will be essential to not go the blockbuster way. That last bit was our words, not hers. Another standout showcase involved Wingcopter's next-gen vertical takeoff and landing drones. Wingcopter is utilizing ANSYS multiphysics and safety analysis simulation tools to optimize drone designs for transporting vaccines, medicines, and conducting long-range LiDAR surveys for infrastructure inspection. Through these simulations, Wingcopter improved its payload configuration, achieving over a 10% increase in flight range, thereby enhancing the drone's ability to serve remote regions. Dassault Systems demoed its 3D Experience platform, which integrates AI-powered generative design capabilities to automate aircraft production, testing, certification, and maintenance. This platform supports building aircraft with improved quality and reduced lifecycle costs by harnessing generative AI to accelerate design iterations. Siemens stood tall with its AI and digital twin portfolio, showcasing how JetZero is using the accelerator to accelerate aircraft design, manufacturing, validation, and certification processes while emphasizing the growing role of immersive digital experiences. Flex Compute introduced new GPU-native radio frequency simulation capabilities that enable full-wave electromagnetic analysis combined with computational fluid dynamics in a unified environment. Their integration with NVIDIA's Blackwell GPUs accelerates simulations, while the addition of GridPro allows structured mesh generation for complex geometries within Flow360 workflows. JetZero selected Flex Compute's Flow360 platform to accelerate the design of next-gen aircraft, including all-wing and hydrogen-powered concepts. Flex Compute's president, Vera Yang, highlighted that their high-fidelity GPU-accelerated multiphysics simulations empower aerospace innovators to rethink aircraft design and rapidly address environmental challenges. As for reliable and free Wi-Fi on board, word around the campfire is that it should arrive sometime between 2040 and the colonization of Jupiter. Recap number 3. World's largest 3D printed building? Qatar loose. Okay, yes, sure. Children are the future. Not wrong, got it. But did you know the future is here now for children? At least in Qatar, where 2 entire conjoined public schools will become the globe's king of the 3D printed hill. Interesting Engineering recently profiled how 2 colossal BOD XL printers, each the size of a Boeing 737 hangar, custom built by Danish firm Cobod and operated by UCC Holding, are fabricating the schools. And they dwarf any previous 3D printed structure by a factor of 40. The BOD XL printers extrude a cement-like mixture through a robotically controlled nozzle, layer by layer, following digital blueprints to build up the structural shell of the schools. This method allows for the creation of complex, curved wall geometries inspired by Qatar's desert dunes. The printers can construct structures up to 5 floors tall with a maximum built-up area of 80,729 square feet per print session. Pre-construction, the crew spent several months preparing the site, assembling the massive printers, and conducting over 100 full-scale test prints at a dedicated facility in Doha. Printing is conducted at night to avoid extreme daytime heat and to improve the strength of the concrete, while also reducing dust and noise pollution. Once the 3D printing of the structural shell is complete, human builders will add roofs, doors, windows, and other finishing elements for fully functional schools. The project, scheduled for completion by the end of 2025, is part of a broader initiative to build 14 new public schools in Qatar, with the 2 3D printed schools serving as a global benchmark for digital construction and scalable, future-ready educational infrastructure. But let's just see if they build a lunch detention room with straw and manure. 115 degrees never smelled so fine. That'll teach those pesky kids. Recap number 4, Freakosytems. Reality capture, extinction, and the complex interplay of Hawaii's birds and plants. Y'all know well that reality capture can bridge people, companies, industries, even countries. Now, it's even bridging conservation. The Lost Manu Research Initiative, Manu is Hawaiian for bird, is harnessing photogrammetry and 3D scanning to tell a story of extinction and rebirth, of independence and coevolution, that is created with some label Freakosytems, who is hopefully opening for Slipknot. It couldn't come at a more opportune time, as native and invasive species and conservation on the whole are molten issues in the Aloha state, because as coevolution occurs, co-extinction eventually threatens. Quote, "If we want people to care about what's lost, we have to show what's beautiful and what's still possible," explains Sam Case, a postdoc at the University of Washington. And by show, he means it. Lost Manu will use museum exhibits, public storytelling and film, and lectures. Reconstructed coevolution of extinct flora and fauna, juxtaposed with contemporary species interaction, will comprise the unprecedented content. Hawaii Public Radio chatted up Case and Molly Hageman, who oversees the vertebrate zoology collection at Honolulu's lauded Bishop Museum. The interdisciplinary project utilizes photogrammetry and 3D scanning technology to document and study the interactions between native Hawaiian birds and plants, both in the present and historically. Game cameras are deployed in the field to capture interactions between birds and plants, helping researchers observe behaviors such as feeding and pollination that might otherwise go unnoticed. Meanwhile, 3D scanning is used on museum specimens, allowing researchers to create detailed digital models of preserved birds and plants. This enables the team to analyze morphological features and reconstruct past ecological relationships, even for extinct species. Case highlighted the importance of understanding, quote, nectar robbing, a behavior where birds extract nectar from flowers in ways that may not benefit the plant's pollination. Hageman discussed the value of the Bishop Museum's collections in providing historical context for the study. By combining field observations with the digital scans of museum specimens, the research initiative aims to build an exhaustive picture of how native birds and plants have interacted over time and how these relationships have changed due to environmental pressures and species loss. The interview underscored the creative use of technology in conservation and the importance of interdisciplinary collaboration to protect Hawaii's inimitable biodiversity. Ladies and gentlemen, you know what else in Hawaii was inimitable? Your AEC Error of the Week. Darn right. Aloha Stadium in Honolulu opened in 1975 with the swagger of King Kamehameha and the promise of engineering profundity. 4 movable seating sections, movable, each weighing more than 3 million pounds, could slide and swivel to transform the stadium for football, baseball, or concerts. It was a shape-shifting marvel until it wasn't. Within a few salty Hawaiian seasons, the stadium's greatest trick became its slow vanishing act beneath a creeping tide of corrosion. The drama kickoff was the original design team cladding the stadium in weathering steel. Now, on the mainland, this stuff forms a protective oxide layer, kind of like a sunburn that toughens into a tan. But in Hawaii's ocean-kissed air, the steel just kept rusting. No protective patina, just an endless exfoliation of flakes. Instead of stabilizing, the steel corroded rapidly, earning Aloha Stadium the nickname the Rust Palace. By the 2010s, inspectors found pronounced section losses, missing bolts, and welds that had parted ways like that couple from the White Lotus. Aloha Stadium's piece de resistance, the movable stands, quickly became an operational migraine. The Aircaster system, designed to float the stands across the field, worked about as well as a surfboard in a lava flow. Subpar concrete pads, built thinner than specified, and relentless corrosion meant the stands could only be moved with Herculean effort, and eventually, not at all. By 2007, the feature was abandoned, leaving the stadium permanently locked in football mode. The only thing moving at Aloha Stadium after that was the rust. Routine inspections became a horror show of cracked seats, missing hardware, and corroded beams. Emergency repairs were as frequent as rainbows, but far less uplifting. By 2020, the state threw in the towel, closing the stadium to the public and setting the stage for demolition. The stadium's final act? A cautionary tale about what happens when you forget that Hawaii's most abundant natural resource is salt water. If only reality capture had surfed in. Imagine if reality capture tech and digital tools had been on the guest list for Aloha Stadium's construction luau. Laser scanning and photogrammetry could have created a detailed digital twin of the stadium, allowing engineers to track every bolt, weld, and beam. Early warning signs of corrosion could have triggered targeted interventions before the rust went viral. Drone inspections could have replaced risky, labor-intensive climbs, providing high-res images of every nook and cranny. Regular flyovers could have mapped the stadium's slow decay in 3D, turning anecdotal maintenance into data-driven action. IoT sensors embedded in the structure could have monitored humidity, salt exposure, and material degradation in real time. Alerts would have pinged maintenance crews at the first sign of trouble, not years after the fact. BIM integration could have enabled clash detection and long-term wear tracking for the complex moving stand system, flagging the mismatch between design intent and the realities of concrete pours. Aloha Stadium was built to be everything for everyone, but it forgot to be anything for the climate it called home. In the end, the only thing that moved reliably was the rust, relentless, undefeated, and immune to good intentions. Today's reality capture and digital tools cannot change the past, but they can ensure that the next stadium built in paradise won't be a monument to maintenance regret. In Hawaii, as in construction, you can't outsmart the ocean, but you can at least see it coming in high definition before it eats your stadium for lunch. That's the week, recappers. Hit those show notes for some Yosemite caliber quick caps, and we thank you for even considering liking and subscribing. Seriously, thinking about it is cool, even if you don't, see ya. Hey, did we get is there working? Okay.